Continuing on with Chapter 7, we are going to talk about Section 7.5, Reflections and Line Symmetry. So you have a new learning outcome. It's to demonstrate an understanding of line and rotational symmetry. Okay, so first of all, it says when congruent copies of a polygon are used to cover a flat surface with no overlaps or gaps, a tessellation is created, and some tessellations have line symmetry. Okay, so let's back up a bit. Congruent, remember, means exactly the same. Okay, so when congruent copies of a polygon are used to cover a flat surface with no overlaps or gaps, we get a tessellation. So let me show you an extremely simple tessellation. Let's say our polygon is a square. Okay, and let's make that infinite cloner. Okay, so let's say I have this shape. I can take this shape and I can continue to use it to cover an area with no overlaps or shapes. So a really simple example of this is tiling. Tiling is a tessellation, okay? Okay, so I can use congruent copies of a polygon to cover a flat surface with no overlaps or gaps. It says some tessellations have line symmetry. Line symmetry means that if you draw a line through the center, it's exactly the same on both sides. So I have line symmetry because this side's exactly the same as that. And the way that I think of it is if I had to fold this in half, if this were on a piece of paper and I had to fold this down the middle, this would exactly cover this. Or you could say I have a line of symmetry here, because if I folded this onto that, it would exactly cover it. Congruent polygons match exactly but may have different orientations. It's saying you could turn them. So in this particular example, when I have a square, because it's a square, I could still turn it and I would still be okay, wouldn't I? But some shapes you may have to turn in order to make them fit. So for example, a right angle triangle, in order to tessellate that, let's make that a cloner, I wouldn't be able to just slide and go, okay, there's my tessellation because I have gaps. So obviously in this one, I would need to rotate it like that so that I could make it fit with no overlaps or gaps. Okay, make it fit exactly. Okay, so example number 1 says identifying the lines of symmetry in tessellations. So let's do this properly with a line. Identify the lines of symmetry in this tessellation. Okay, so it means right through the middle, and one side is exactly the same as the other. So the obvious lines of symmetry, of course, are there and there. So we have a horizontal line of symmetry and we have a vertical. The other way around, sorry. We have a vertical line of symmetry and we have horizontal. Remember, if this was a piece of paper and I folded it along this line, this bottom would completely cover the top, or the left would completely cover the right. Now there's a couple more lines of symmetry, and they are here and here. Because I could fold it diagonally on top of itself and it would completely cover it, and I could fold this and fold it on there. Okay, so the lines of symmetry would be one horizontal, one vertical, and two diagonals. Okay, the check says draw the lines of symmetry, and it says use a mirror. Well, a mirror is just this funky mirror you put up and so that you can see if it completely covers. It's just a way to not fold the papers over. All right, so it's asking you, is there a vertical line of symmetry? Remember that lines of symmetry have to pass through the center of the design. So have a look at this. Do you think there's a vertical line of symmetry? Hopefully you said yes, it's right here. Okay. Is there a horizontal line of symmetry? You bet, it's right here. Diagonal. Do you think that if we put that through there and folded this section on top of this section, would the dots line up? Okay, would this dot completely line up with that dot? This dot would have to line up on that dot. This one would have to line up, and you can probably see that absolutely it would. And the same with that one, okay? So this is exactly the same example. We would have vertical, horizontal, and diagonal lines of symmetry. All right, what about example B? Do you think there's a vertical line of symmetry? Remember, it has to go through the center of the circle. So is that a line of symmetry? Will this side completely cover this side if it got folded on top of itself? And obviously, yeah, it would. This point would match up with that point, this corner with that corner, etc. Horizontal line of symmetry, same answer. Yes, this top would completely cover and match up the bottom. Okay, so yes, we have vertical and horizontal. But diagonal, you know what? Because this isn't a perfect square, we wouldn't have a diagonal line of symmetry. If you put a diagonal line right here, you know what? It wouldn't match up. This actually would kind of end up here. It wouldn't, there's no way this would completely fold onto that corner. So no, rectangles do not have diagonal lines of symmetry. It won't work. Okay, and if you're ever wondering though, if the shapes, if you're struggling with a shape and you're not sure if it will or not, trace it onto a piece of paper and fold it onto itself and see if it does work. All right, two shapes may be related by a line of reflection. So in example number 2, it says, which triangle is a reflection of the shaded triangle? So reflection means that it folds over onto a line, okay? So the shaded triangle is the original. Okay, so I'm going to make it a little darker here just so you can really know we're talking about this triangle. This is the one we're talking about. Okay, so it's asking, do you think that triangle 1 is a reflection of this shaded triangle? Do you think there's a line of reflection that exists that would reflect this onto this? And the answer is yeah, that line of reflection is right here, of course. Okay, so this dot would become that dot. This dot here would become that dot, and that dot would go over there. So number 1 is yes. How about number 2? Is there a line of reflection that would make this into 2? And hopefully you're thinking the answer is no. Because if I reflected it through this line here, this would end up all the way here. And it would look, can't draw straight, but it would look like that, not like number 2. So only number 1 is a reflection of the shaded triangle. All right, try the check. Number 1, which polygon is a reflection of the shaded polygon? So pause, give it a try, and then come back and check. Okay, so example number 1, or sorry, polygon number 1, do you think that this line, which is right in the middle, would result in this reflecting onto this? And hopefully you're thinking no, because if it got reflected, it would look like this, wouldn't it? It wouldn't look like the one we have. So number 1's no, there's no way to reflect it. All right, number 2, the reflection line would have to be here. And absolutely, okay, this would end up here. It's 2 spaces away. Okay, that would end up there, and that would end up there. So example 2 is yes, it is. Okay. Okay, example number 3 says completing a shape given its line of symmetry. I think you'll find this very easy. It's all about the counting of the squares. It says reflect quadrilateral ABCD in the line of reflection to make a larger shape. All I can suggest to you to make this easier is sometimes it helps to just sort of really brighten up your line of reflection. Make it so that you can easily see it. But once you have that, it's all about counting squares. So let's start with point A. Point A is on the line of reflection, so it can't be reflected over it. It's sitting on the line of reflection, so it's not going to move. But B is 2 squares away from the line of reflection. So all you do is go 2 squares over, okay, so that it's 2 away. C is 2 away, so make this point 2 away, and D is sitting on it, so it's not going to move. Okay, so I will join my dots, and there is my reflection. Okay, and when it says to make a larger shape, they're talking about this hexagon thing. All right, now you don't have to go through all this if you want. I don't think it's necessary to try to write down ordered pairs. It's as simple as counting squares. Okay, but it is helpful to highlight or make brighter your line of reflection just so you can see it a little better. And let's make it yellow so we can see better. Okay, so start and just count squares from every single point. So E is on the line of reflection, so it's not going to move. Move to F. 2 away, so count 2 over. G is 1 away, so count 1 over. H is sitting on, so it's not going to move. I'm going to try to make this look a little nicer. So connect E to there to there, and there to there, and there's your larger shape, okay, with a line of reflection helping to create it. Simple as that. I don't think you'll find any problems with this lesson whatsoever.